Hello friends, I am Dr. N.S. Naik from the Department of Structural Engineering, Sanjeevani College of Engineering, Koparga. Friends, in succession with the last video, now here in this video we will discuss about how to calculate kinematic indeterminacy for different types of structures. We have already discussed about the definition of kinematic indeterminacy. Kinematic indeterminacy is defined as the number of non-zero displacement of the structures or the degree of freedom offered by the joints for a given type of structure. So we have already discussed this definition in the last video. Now let us refresh the types of supports and the degrees of freedom offered by each support. We know hinge support, if provided for a beam, it offers single degree of freedom, that is one rotation. In case of frame also, it offers single degree of freedom, that is one rotation. When roller is used for beam, it offers single degree of freedom for beam, that is rotation, and in case of a frame it offers 2 degrees of freedom, one rotation and one translation. Fixed beam, it does not, fixed support, it does not offer any degree of freedom, so 0 for beam and 0 for frame. In case of a spring support, it offers 2 degrees of freedom, one rotation and one translation. Frame, in case of a frame, if spring is used, again the degrees of freedom remains same, one rotation and one translation. In case of a guided support or slider, it offers single degree of freedom in case of a beam, that is translation in vertical direction if it is provided like this, and in case of a frame again single degree of freedom, that is translation. Internal hinge, if inserted in a beam, it offers 3 degrees of freedom, 2 rotations and 1 translation. Again in case of a frame, it offers 2 rotations and 1 translation. Now let us discuss different types of beams and let us discuss how to calculate degrees of freedom. Now in case of a beam shown in figure, the left hand support is fixed, therefore degrees of freedom at left hand support is equal to 0. Now here this is a hinge support, it offers 1 degree of freedom. So if you name this support as C and this is B, then there will be one slope at C and there will be one slope at B. So total degrees of freedom offered by the supports for this particular beam is equal to 2. Hence we can write degree of kinematic indeterminacy for this particular beam is equal to 2, namely theta B and theta C. You can refer this table. In case of a hinge, only one rotation at the support for beam. For frame, only one rotation at the support, and hence one rotation at B and one rotation at C. So degree of kinematic indeterminacy is equal to 2. If we study the deflected shape of the beam, it will deflect like this. This is rough shape, approximate deflected shape of the beam. So this is single rotation at B and this is single rotation at C. Thus degree of kinematic indeterminacy is equal to 2. Let us come to the next beam. So in this beam, the left hand support is fixed, right hand support is fixed, therefore degree of freedom at fixed support 0, degree of freedom at fixed support 0. Now here this roller cannot move in horizontal direction. If you come to the table, in case of a beam, if roller is used, only 1 degree of freedom is there and that is rotation, and therefore if this support is named as B, so only one rotation is possible at this support and that rotation is theta B, slope at B. So for this beam, the degree of kinematic indeterminacy is equal to 1, means only 1 degree of freedom is there. The beam will deflect like this. Remember, this is approximate shape. It is drawn just to explain you what is theta B. So this is theta B to the left of support, and here if you extend this tangent, this is theta B to the right of support. So only 1 degree of freedom is there, and hence the kinematic indeterminacy for this particular beam is equal to 1. Now here also the fixed supports are there, 0 and 0. So here one rotation at this support, say theta 1, and one rotation at this support, say theta 2. Therefore the degree of kinematic indeterminacy for this particular beam is equal to 2, is equal to 2. Now here the left hand support is fixed, 0 degrees of freedom. Then there is a hinge support internal, 1 degree of freedom will be there. Say this is support B. If we call it as support B, this is theta B. So one rotation is possible at B. You can refer this table at any time. Okay, and now this is which type of support? This is spring support. In case of a spring support, kinematic unknowns for beams are 2 theta and delta, one rotation, one translation. So here I will draw deflected shape of the beam, roughly or approximately. So here it will deflect something like this, and if you draw tangent at this support, so one slope will be there. If we name this as C, then theta C will be there. Similarly, in this case the support is moving in downward direction. C moves to new position now. So this is new position of C, say C dash, and hence this vertical displacement is there. This vertical displacement is there. So along with theta C, delta C will be there, and thus degree of kinematic indeterminacy for this beam is 1, 2 and 3. So degree of kinematic indeterminacy for this beam is equal to 3. So in this way simply we have to calculate the number of unknown joint displacement. Displacement, it may be a rotation, it may be a translation. Let us come to the next beam. Now here as the figure shows, this is fixed support, so 0 degree of freedom. Now this is internal hinge. This is internal hinge. Say at B, internal hinge is there. Now let me change the color. Right now for internal hinge, what is the condition? If internal hinge is there, it offers 3 degrees of freedom, theta 1, theta 2 and translation delta. So let us see how it works. Here this is fixed support, therefore there will be no freedom, 0. This is 0. Now roughly I will explain the significance of this internal hinge. Let us ignore the elastic curve, how it bends. I am just drawing the shape for your understanding. So this is delta B. It moves in downward direction. It moves in downward direction to new position B dash. So one displacement is there, and if you draw tangents to the elastic curve, means here also you can see this is theta 1 and here this is theta 2. So at internal hinge there are 3 unknown joint displacement, 2 rotation and 1 translation. So degree of kinematic indeterminacy for this beam is equal to 3. Now let us come to the next beam. Here this is hinge support. So one rotation is possible. Here roller support, one rotation is possible. Here roller support, one rotation is possible. And hence degree of kinematic indeterminacy for this structure is equal to 3. Here 0 degree of freedom, fixed support, 0 degree of freedom, fixed support, roller is there, so only one rotation is possible, theta. So degree of kinematic indeterminacy is equal to 1. For this beam, 0 degrees of freedom, 0 degrees of freedom, 1 degree of freedom here, one rotation here, one rotation, that is say theta 1, here this is theta 2, and hence the degree of kinematic indeterminacy is equal to 2. Now in case of a truss is a different type of structure. In case of a truss, these joints, these are the joints which cannot resist the moment. This is pin joints. This is pin joints. In case of a truss, at a point of a plane truss, there is in general two translations along x and y directions. So only when the joints are transferring the forces, vertical or in horizontal direction, and hence at a point of a plane truss there are in general two translations, one along x direction and second along y direction. There is no rotation possible at these joints, okay, and hence the degree of freedom in case of a truss, two translations for each joint. So each joint there are two translations, one in x direction, second in y direction. And if the truss is supported on roller, then in that case one translation component for each roller support we have to add in horizontal plane, and if it is on the inclined plane, then there will be two translation components, one in x direction and second in y direction. So let us see how to calculate degree of kinematic indeterminacy for a truss. Now, at a point of a plane truss, there are in general two translations, one in x direction, second in y direction. So, how many joints are there? Now, here this is joint A. So, for joint A, there will be two translation components, one in x direction and the second in y direction. Similarly, at B, one translation in x direction, second translation in y direction is possible. Remember, these are the supports, D and C, these are the supports. We are talking about the joints. So here two translations are possible, two translations are possible according to this point, okay, or according to this point, two translation components for each joints. Now let us come to the supports. Now for support, here we have written one translation component for each roller support in horizontal plane. So this roller is in horizontal plane. So here one translation is possible in horizontal direction. It may be to the left or to the right. And thus for this particular truss, there are there are four components, two for A, two for B. So see, two at A, two translations at B, plus one translation at D, and thus there are total 5 translations or degrees of freedom, and hence degree of kinematic indeterminacy for this truss is equal to 5. Means how to calculate it? Simply you have to calculate number of joints. Number of joints are 2. Hence 2 into 2, 2 into 2, 4, and one roller, 5. So degree of kinematic indeterminacy is equal to 5. Now let us come to this, the second truss. Now we will calculate the joints first. 1, 2, 3, where translations are possible. For this joint, translation in x direction, translation in y direction. For this joint, translation in x direction, translation in y direction. For this joint, translation in x direction, translation in y direction. Okay. Here we are not calculating the translations because these supports offer the reactions, and these reactions will prevent the translations. So here we are not calculating, this is support. Let us come to the roller support. We know when roller is resting on horizontal plane, one translation is there in horizontal direction, either left or to the right, and hence how many translations are there? 2 at this joint, 2 at this joint, 4 plus 2, 6 plus 1, 7, and hence for this truss the degree of kinematic indeterminacy is equal to 7. There are 7 unknown translations for this truss. So in this way we can calculate the degree of kinematic indeterminacy for different structures. Now if a roller is resting on an inclined plane like this is inclined plane and the roller is resting on an inclined plane like this, and this is the structure. And let the other support is resting on a horizontal plane. So in case of the roller support, we are considering the two components of translation, one in x direction and second in y direction. Actually this roller, it moves along the plane like this along the plane. Here also it is moving, or rather it can move along the plane in horizontal direction. Here it can move along this inclined plane, and this component we can resolve into x and y. And hence when roller is resting on inclined plane, we have to consider two translation components at that support. So in this way we can calculate degree of kinematic indeterminacy for different structures. Thank you.